Good afternoon, everyone. My name is Rahul, and we are Team 11. This presentation is about our Smart Tracker warehouse inventory management system. So let's dive into the world of warehouse inventory management and the challenges it presents. In warehouses, efficient tracking and organization of inventory items are crucial for smooth operations. However, traditional methods like manual processing and two-dimensional tracking systems often fall short in accurately managing inventory, especially in complex warehouse layouts. Our Smart Tracker project aims to address the challenges of warehouse inventory management by implementing an innovative solution. We have identified key objectives, including designing an indoor asset system and utilizing BLE, Bluetooth Low Energy, and Wi-Fi technology for real-time location tracking. Our proposed solution involves the deployment of BLE beacons attached to inventory items and shelves, along with a centralized server and cloud database for data management. With a Smart Tracker system, we anticipate improved inventory management, streamlined picking processing, and overall efficiency gains in warehouse operations. Now let's move on to the hardware and software components.
Hi, I am Shreya. I will be presenting on the hardware and software component. The hardware component required by our project are two laptops, one used for the client and another used for the server. We will need four M5 sticks C+, with 3 used for tracking inventory information such as which shelf it is located in and if it is located near the top or not. And we will use one M5 stick C+, that act as a server. Then next, the software components. So we use various protocols for our final product. Firstly, the Bluetooth Low Energy. We use the Bluetooth Low Energy signal to read the RSSI value and to determine the inventory location. Then next, we will have the Wi-Fi, which involves connecting all the devices together, updating the database constantly with the updated information received from the BLE signal, and also for running and updating the server web page constantly. Then client server. So for client, after receiving information about the inventory, we will communicate and update the database. Then for server, we constantly retrieve information from the database to display the up-to-date information in the server web page. We also have a cloud database, which we use the Google Firebase. We store the up-to-date inventory information, which will be used by both the client and the server. Then lastly, we have the REST protocol that handle all the HTTP requests and response to the web server.
Next, we'll be moving on to setting up of the IoT devices. So I'll be starting off with the BLE beacon side. So for the setup, we'll be making use of 2 codes. One will be for the BLE shelf, as you can see here, and the other will be for the inventory. So for the BLE shelf, the main things that have to be updated would be the Wi-Fi credentials, as the current setup sends the location of the inventory after calculating it through the threshold back to the cloud database. And then we also have to adjust basically the shelf thresholds if needed. And for the rest of the part is basically just scanning for the inventory device and seeing where the location of the inventory is. Also, in addition, there will be a unique shelf name that you have to be defined so that when it is entered into the database, it can identify it. So this is the code for the BLE inventory. So as you can see, firstly, we have to change and uniquely identify it with an inventory name for the database. And then finally, we will also have to key in and give it a unique UUID that we'll be using to identify this inventory. So moving on from this, so the shelf code will be pumped into one M5 stick, which will be located at the top of the shoebox. This inventory code will then be pumped into another M5 stick, which will act as the inventory. So this is how the Firebase cloud database looks like. If you were to use a new inventory UUID, you will have to add in the UUID to this inventory UUID table, as this is where the BLE scanner will identify the BLE inventory devices. So this is where the BLE scanner will be on top of the cardboard shelf.
For the web server, the hardware setup is to connect the M5 stick to the laptop. On the software version, first we download the platform IO extension on VS Code. To set the web server up, create a new project and select the M5 stick board and the Arduino framework. Save the files from the GitHub repo and change the main PPP file in the SRC folder. Create a data folder and save the dashboard HTML file. Next, we add the libraries needed in the project, which includes M5 stick C+, Arduino JSON, and ESP32 Firebase. We then use the platform IO sidebar for the upload file system image so that the HTML file is uploaded and the setup is done.
Moving on to connecting devices to IoT platform. We'll be using our system architecture diagram to elaborate on this section on connecting devices to IoT platform. The slide shows a pictorial view of the system architecture of our demo setup. We will make use of 2 cardboard boxes that act as shelves. There will be a single BLE beacon 1 and BLE beacon 2, which acts as a scanner, which can be seen in the slide, that will be placed on top of each shelf that acts as a scanner where it receives Bluetooth signal via BLE technology. There will be also an inventory which has an BLE beacon BLE beacon 3 tied to it as well to emit RSSI signal via BLE technology to determine the location of the item. Once the scanner has determined the location of the item, it will send the updated location back to the database by sending the location data over via Wi-Fi. The web server will then retrieve and update the information from the database for the inventory management via Wi-Fi as well. So, the purpose of the IoT platform, which encompasses 4 sections. Firstly, the database management software. It stores and retrieves inventory location and information. Next, the BLE beacon, which is in this case our M5 Stick C+. It is attached to the inventory items and corners of the shelves to emit Bluetooth signal containing coordinates. Then, moving forward to Wi-Fi signal, it facilitates the transmission of the information between beacons and the server. Lastly, our central server software, which is responsible for processing data and receive from tracking devices and managing database connection.
Now we will be moving to IoT in action, where we will be showing you our prototype and how it works. This is how the setup looks like currently, simulating the shoebox as a shelf. So as you can see, as I move the inventory M5 stick higher, on the shelf, the M5 stick above on the shelf, the scanner would detect it based on the threshold and basically, as you can see, update the database accordingly to the inventory, which is currently at the top part of the shelf. And as I place it down back, the scanner will scan it again and check the location of the inventory based on the thresholds that are being set. And it's currently the database will be updated to the bottom part of the shelf. So as I take the inventory out of the shelf, the BLE will scan that it is outside of the threshold, and it will update the shelf and location of the inventory as both unknown. And as you can see, then it is updated in the database itself. Next, as you can see, I have set up another shelf as well, that is different from the shelf that you have seen previously. And so this is to show basically how the inventory can move from shelf to shelf and how the location can get updated. So currently the inventory is marked as unknown, the location, and then as I put it into the shelf, the BLE scanner above the shelf will scan and detect that there is the inventory there, and it will update the database accordingly to it. So basically through this, we can see how the inventory moves from shelf to shelf and how the location is being able to be updated onto the cloud database, which kind of simulates in an actual warehouse scenario where the inventory moves from shelves to shelf.
To view the web server in action, simply change the SSID and the password in the main CPP file and M5 burner if it has not been configured yet, and upload the code into the M5 stick. Use the IP address displayed on the M5 stick and add /dashboard. Which brings us to this page. The page has been set to refresh every 10 seconds such that the tables get updated with the information in the Firebase database. It's refreshing now. Here we are adding the eyeliner object in the database. The web server displays the change through the 10-second refresh. Next, we'll move on to the shelf side.
So we have come to the end of our presentation demo. And so in conclusion, we have managed to see how we utilize BLE technology for inventory management in warehouses and how this approach involving BLE beacons and Wi-Fi is able to provide real-time accurate location data for inventory items in order to optimize warehouse management processes and enhance efficiency. We have also conducted prototype testing and analysis to demonstrate the BLE's potential in revolutionizing inventory management. And moving forward, we will focus on refining and optimizing for real-world implementation of our current proposed solution. Thank you.